Welcome back. Today we have a fun video. This is going to be an implementation video, a demo video, and I'm going to try to keep it still somewhat short, but unfortunately we're going to try to do the entire implementation in one video. I thought about splitting it up, but decided it would be much better to have it in one place. So this may end up being a little longer, but I'm going to try my best to edit repeats and keep it short. So let's get started. All right, so what we're going to do today is we're actually going to take this project that we did a few videos back where we built this ping pong game using AI. And if you haven't seen that video yet, you can check out that link. I'll put one in the description. And we didn't write any code ourselves. We told the AI what to do. We gave it some prompts and it generated some code, which I did not like. I asked it to make it more object-oriented, so it sort of did some things. And it did what it did. It at least in this version, we didn't really quite get it to work correctly. But so today what we're going to do is we're going to take the opposite approach. We're going to take our design that we started working on in the previous video, and we're going to implement that design without taking any help from AI today. Okay, so when you are working on your codes and your designs, ideally, you would do the design yourself, and then when you're writing the code, you can get the AI's help if needed. But the design needs to be yours so that you can logic behind the code instead of seeing all this hodgepodge code and you have no idea what the design behind it was. So today, we're going to control the entire design. So I'm going to save this as a copy, and let's say ping pong, no AI. All right. Um, and I'm going to take out all this stuff that the AI did. Okay, so this is what we're going to start with. This does nothing right now. Okay, so it just says, welcome to Ping-Pong. So what are we doing? So let's just quickly remind you what we worked on last time. And this is a model that we created. And this is basically what we ended up with. Off camera, I have added a few things. Like, for example, I've added, I think, show welcome, move ball, which direction we're going. We also added checking for foul or hit. So these are basically, if you remember when we looked at the, created the state model, and if you don't recall building the state model, I'll put a link to that video here as well. There were things like move ball, check foul or hit, player point, show result, those types of things. In that design, we were kind of, cheating a little bit and saying player one serve, player 1 point. But I think it's a lot better to have just a single method and pass the parameter of which player you want to want to give the serve to or the point to. So those are the changes that we made. You can pause the video and take a look at this class state diagram and compare it with what you have if you worked on that diagram on your own. So the other change that we made was I incorporated the state model class. This is a class from PicoLibrary, and this allows us to have a state model and have an implementation of that state model. Most of the driving of the states is done by the library itself. So all you have to do is implement these callback methods: stateEntered, stateLeft, stateDo, stateEvent, and the run is what makes everything work. So this is basically what we will need to do to drive the state model. So today in this video, we're actually going to implement the state model. And as we implement it, there may be certain changes we have to do to the model, and that's okay. What I'm going to try to do is try to do a lot of the coding off camera so that you're not watching me type a lot of code, but instead I'm going to pause and show you what code we landed up with before we do that. All right. So that being said, let's get started. So first thing that we will need to do is we will need to go back to our code and we're going to upload a couple of files. So we're going to say upload, and within the Pico library, you'll see there are two files. One is called model template and the other one is called state model. Model template may not be the right name for it. It's more of a controller template, but the state model is that class that I just showed you in the model, this guy. Okay, so if you look at the state model class, this is my implementation of a state model driver. I've created something that is easy to understand because it tells you, you create the states, you create the transitions, and then you implement these callback methods. And there's quite a lot of comments here that you can read through to see how this state model works. But this is what we're going to be using. Now, this model template, this is going to be our controller class. So we're going to change the file name to Ping-Pong controller. And we're also going to change the name of the class from my controller template to Ping-Pong controller. So this is something that I have kind of created as a starting point. So if you're using my state model driver to build something, using this controller will at least give you some ideas on what to do. All right. So the first thing that we're going to do is just kind of go through the steps. First, we have to instantiate whatever classes from your own model that we need. Let's just time lapse through creating the display, the buzzer, and the light strip classes. We have done this several times, so there is no need to go through the entire process. All right, so these are our view classes. And we also need a model class. So let's go ahead and create that. Create the model classes and instantiate those. Now notice that we don't have any of those here. So what we will need to do is we're going to have to create them. So this is where we're going to create a new file, and let's call it ping-pong classes.py. Okay. We're going to put all of our model classes in here. So this is one place where I'm going to save some time and just copy paste some things that I already worked on. So first, let's see what we have here. I've got the game class. So let's take a look at the game class, which has a player 1, player 2, and ball. Let's call it player 1, player 2, and ball. So we created 2 players, and all right, so what we're going to do is there's the init method, and the init method takes 2 names for the 2 players. So we are going to add these to our here as well. So init and P1 name, P2 name. So you send 2 names of players and it creates those. I also created a reset. So every time you start a new game, you're going to reset, right? So you're going to reset the points of the players, and we're going to reset the ball's position to player 1. So what we're going to do is we're going to add another operation called reset. And that's just simply, it resets the stuff. Now let's take a look at player. I was actually thinking about some of the things that we could do cool things with player. So again, just like before, we have name, home position, and let's give each player a color too. It's kind of a fun that we could do. Name, let's do a home position. Home position, int. So the player has a name, a home position, a score, and a color. And so we're going to have an init that takes the name, home position, and color. Sorry. So we're going to create an operation called init. name, home, color, right? And then also we will need a reset that resets the score. So we will add an operation called reset. And then we're going to need to make sure that there is a way to give the player some points. So we're going to add an operation called point. And all that does is gives the player 1 extra point. That's basically all this player class does. And you see all of them. Now ideally what you should do, and this is kind of important, that you should give documentation to your classes. I do not want to spend time in the video writing documentation, but these are something that is extremely important. Not just documentation of classes, but also documentation of all your methods, including the init method, right? So we could do reset score to 0, something like that. And it is important, it's going to come more handy later on as we go into some of the more tricky methods, because that's where documentation is extremely important to know what does this method actually do. So far, most of these don't really do a whole lot. Just one thing we could do is we could say, we could actually say that the point, when you give the player a point, that point is returned back so that you can use it. So you can see I'm adding 1 to the score, and then plus I'm returning the score back to the caller. So so here, this is important to write that in your comments. All right, so there is the player class. So here is the entire player class, which has init, it has a reset and the point. Now, finally, we've got the ball class, which has a position, direction, and color. And what are some of the methods we need to do with it? Of course, we need an init method to initialize them. We need a reset method. Now, the reset method, I am giving a player as a parameter. So when you reset it to reset the ball's position to one of the players, right? You don't usually put the ball in the middle of the board, or at least not in our implementation of the game. So we will reset it either on the player 1 side or player 2 side, right? When one player wins the point, the ball gets reset to that player's position. So that's why we kind of want to do that. And then we have a move that takes, and this is the part that is a little tricky. That's why we will say that this returns a Boolean, and let's see what we need to do in this method. So in this case, we're not doing any loops. The looping is going to come from the outside. This only does one step of the ball, and then we will have the controller do the movements itself. So this is just one step of the ball move. Now, what is important, why does it return a Boolean? So when you move the ball, it is possible that it will move out of bounds, right? Now, if you move out of bounds and you try to display that, obviously your program is going to crash because you can't display something at position -1. So we're not going to actually change the position of the ball to an illegal position, but we will return back saying whether or not it went out of bounds. Okay, so this part is important. This is what I decided in my design to implement. So this is why commenting and documenting your code is extremely important. So let's see, we created an init, a reset, and a move. So far, hopefully, all of these are easy to understand. So again, we're going to add the operations. Okay, so those are the balls methods. So this is how you do the designs for your classes. All right, now that is done, hopefully that kind of takes care of our model classes. Now we will see and how we implement these in our controller. So now that we have our model classes, we can now say self.game equals, and did I call it game or ping pong game? we just called it game, class game. So we will say this is game, but we need to give it two player names. We're just going to say P1 and P2. So those are the two player names. You can give it other player names as well. So there is our model instantiation. Remember that Ping-Pong controller controls the game, so that's basically the game. So we probably should add that attribute in here as well. Game for that. So these are all the classes that we need. So that's the first step. Instantiate whatever classes from your own model that you need. Of course, I got light strip, LCD display, passive buzzer, and game. So those things we do need to import. No, so that would allow us to use these classes. Now let's create the state model. The state model takes three parameters: number of states in the state model, who's the handler, which is typically self, and we're going to leave debug as true so we can see some messages from the state model coming up, which will be really handy for us. Now, our state model has how many states? Let's go back to the state model and see. Here is our state model. And if you see that there are 10 states, so 0 through 9. So these are all our state model states. So we need to have 10 states. All right, that's done. Now instantiate any buttons. We have two buttons. And now we're going to add those two buttons to the state model. So this allows the state model to handle all the events from the buttons. So you, as your programmer, you only deal with the events. You don't need to worry about the button presses and all of that. So that's done. We don't need any timers. So I'm going to comment that part out. So that part is done. Add any custom events. So this is the next step that we will need to do. That there are a whole bunch of custom events in our model. So we are going to need to add those custom events. And what I'm going to do again to save time, I'm going to copy and paste the events list of events that we already have so that you can kind of see what those are about. So here are our custom events. And here's how you add the custom events. You say self.model. Model is this guy that we just created. And we say add custom event and then the events that you want. You can see out of bounds, foul, valid return, and game over. These are names of our 4 custom events. So that's important to remember that when you add the custom events, all you're doing is you're giving the state model names that it should use to do the transitions, but it doesn't know anything about what those events are. It only knows about the names. So you as the programmer will need to implement when should these events fire. We're going to see that in a little bit. But let's just quickly take a look at our state model. That way we would know here is out of bounds. That's a custom event. Foul is a custom event. Game over is a custom event. Valid return is a custom event. These events, P1 press, P2 press, no event, these things are built into the state model. You do not need to create custom events for those. Any button presses, event, timer, timeouts, and then the no event, of course, those things are all built in. Now comes the important and sort of complicated phase, and this is probably the most complex part in this implementation, is creating all the transition. So if you look at the state model, you have all of these transitions. You have all these arrows. These are all transitions. So what you will need to do is you'll need to tell your state model in your code, what are these transitions? I'm going to write a couple of them, and then I'm going to copy and paste code from something I already prepared. So I've got a welcome state, 0. And if I get P1 press or P2 press, so this is where I'm seeing a welcome message on the screen, and it's saying, hey, welcome to Ping-Pong or something like that. Press a key, and you can press either of the keys, and it's going to go into the serving state. Okay, so the way you do this in this code is you say self-model add transition from state 0, so this is the source, and all of the events that could potentially cause this transition. So you say P1 press in an array, P2 press. So this basically says either P1 press or P2 press happen. We're going to go from state 0 to state 1. My state model implementation uses these numbers. So it would be nice to use the names, but I use the numbers to keep the code reasonably short. All right, so here is our first transition. Let's do a couple more, and then we will go ahead and do the press. So let's do this one. From state 1, if I get a P1 press, I will go to state 2, right? So that's pretty easy. We say model add transition from state 1. If I get a P1 press, we go to state 2. Let's do one more. From state 2, yeah, this is important. So now we're going to use a custom event. So there are two outgoing arrows from state 2. If I get out of bounds, I go to state 4. If I get P2 press, I go to state 3. Okay, so let's do these two. So we say self.model.add transition from state 2. If I get out of bounds, we go to state 4, I believe. From state 2, out of bounds takes you to state 4. P2 press takes you to state 3. So let's put it before then. Self.model.add transition. From state 2, if I get P2 press, we go to state 3. Okay. Now, we've got 4 of them. If you look at your state model, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 arrows. Okay. So that means there should be 16 lines of code, 1 for each arrow. So this is the part that, as I said, it's a little tedious in this process, but this is essentially taking the diagram that you have, the model that you created, and putting it in code. And that's the part that is important to understand, that all the work that you spend designing, it comes exactly in handy when you write the code. Designing is the most important. Once you have a good design, writing the code is just kind of like a translation system. What is also important to understand is that you can actually, when you add these things, I would suggest running every time you add something so that you can kind of see how your code is working. Of course, it's not doing anything now. That's because we did all this work creating our Ping-Pong controller. We are not actually running this thing. So what we're going to do is go into main and there. Of course, nothing happens. We haven't really done anything with it. But notice that it created the buzzer, it created the buttons, it created the display. The display lit up. It's not showing anything because we haven't written any code to show anything. But notice that it says state 0 entered. So it's already started with state 0. And we can actually test out some of the functions. In state 0, if I push any of the buttons, I should go to state 1. So if I go push 1, notice that you will see state 1 entered on P2 press, and then it gives you an error saying, there is no attribute timer. Oh, yeah. Let's go ahead and remove that because my template does reference a timer, which we do not have, right? So we went to state 1 and tried to start a timer, which we commented out other places. Is there other instances of timer? Yeah, we have other places where we use timer. So we're going to comment those out as well. All right, so let's run it again. Line 121, invalid syntax. Elif state 1, there is nothing. So that's invalid syntax. So we're just going to say pass for now. So at least it goes through compilation. All right, so we should now have, at least we can show a couple of transitions. So state 0, right now we are in state 0. Let's hit one of the buttons. And now notice that we are in state 1. Now from state 1, if I click on this button, I should go to state 2. So let's click on this button and notice that it says state 2 entered. So far, all of our transitions are working properly. So this is actually good. Now, obviously, any transition that happens on a custom event won't work at this point because we haven't implemented those yet. So we're going to do that next. The next thing I'm going to do is go back to this list of transitions, and I'm going to paste in transitions that I have pre-created, but we're going to just look over them. You can pause the video here to see all the list of transitions to see how that worked out. So we had up to here, right? From 2 out of bounds, we went to 4. So now let's look at from 3, valid return goes to 6. So from 3, valid return goes to 6. From 3, a foul will take you to 4. From 3, a foul will take you to 4. From 4, no event takes you to 1. Right? So from 4, no event takes you to 1. And from 4, game over takes you to 9. From 4, game over takes you to 9. And then you have exactly the same set of things, but the important thing to note there is the changes from instead of 1, 2, 3, 4, we created 5, 6, 7, 8. Whatever was P1 press here becomes P2 press. Whatever was P2 press here is P1 press. So that's the symmetry of the game. So this is the player 1's side.
And this is player 2's side.
So now let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So as I said, there are 16 arrows. We need 16 lines of code for all the transitions. You can pause the video here and you can look back and forth to make sure that I did not make any mistake here. All right, so now our transition table is ready. We are now ready to actually do some of the implementations. And we're going to try to do, because this is the exciting part. As we are building it, we can actually start seeing things working. Okay. What happens in state 0? Welcome state. We're going to show a welcome message, right? It's going to show something on the display saying, welcome to Pong, press any key or something like that. So those are some of the things that we're going to do. I am going to create a couple of quick methods. All right, so I created 2 methods here. One shows a status on line 1. So the display has 2 lines, right? It has line 0, that's the top line, and the line 1, which is the bottom line. What we're going to do is we're going to use the top line for the score and the bottom line for the status, like press any key or player 1 to serve, something like that, right? And then, so show welcome is going to reset the game and all of that stuff, and then it's going to show welcome to Pong on line 0, and it's going to show the status press any key on line 1. Okay, so let's go ahead and run this. Well, yeah, we just created this method. We haven't called show welcome yet. So if state is 0, so this is stateEntered. This one does have an entry. So here we're going to call the controller show welcome method. So we will say self dot show welcome. So you notice that exactly what you did in the model, in the design, is what goes in the implementation. That is important to know. You spend all the time creating this diagram. Now all we are doing is looking at the diagram and putting the right methods in there. So there it is, show welcome right there. And we can actually run this and test to make sure it works. There you go. Welcome to Pong, press any key. This is now show welcome. So this is where state 0, and if you look at the log messages, it does say state 0 entered, and this is where it's showing all of the messages. Done. Okay, so the next step is we're going to go to, let's see, state 1. Player 1 serve has an entry. It says player serve on player 1. So we change player 1 serve to use the parameter. So let's just take a look at creating that method first, and then we will call that method. So what we will do is first create that method. So here is my player serve method. It's called with a parameter, right? When that happens, we're going to reset the ball to that player's position. So there are two players. When that player is serving, the ball goes to that player. So as I showed you, the reset for the ball takes a player parameter and puts the ball at that player's parameter. We're going to show the ball, okay, on the light strip. Okay, so what we will need is we're actually going to get the show ball method. And again, show ball. Let's call show ball. And show ball is pretty simple. We turn the board off and then we set the pixel to at that position, whatever the position of the ball is, we set it with that color of the ball. So notice that this is where we are actually using the models. So now let's see if this works. So when you are in state 1, in the state entered, we need to call player 1 serve for player 1. So what we will do is self.player serve, and we'll say self.game.player1. Okay, so player 1 is now serving. All right, let's see. There, welcome to Pong. Press any key. We're going to press the key. And now it says P1 to serve, and notice that the ball is now showing on player 1's side. Okay. Nothing else works at this point because we haven't implemented any of that. All right. So now let's go to other state entered. State 2, notice that does not have an entry. State 2 has a do because it needs to continuously loop and move the balls, right? So let's go ahead and do the state do. Now, if you look at the callback classes, there are 3 callback classes. Just like the model, well, actually 4 callback classes, just like the state model says. The only thing that I do not have implemented is a substate. So I do not have an implementation of substate, but all the other things, anytime a state is entered, you get a callback saying which state entered, and we also get which event caused this transition to happen. Same thing for state left. So when you are exiting the state, you can have something happening at that state. The state event is where we talked about state modeling, where an event comes in and you're doing something without actually transitioning out of the state. And then finally, state do, right? This is the good one that we will need to do, is where something that happens for each state. So we are not doing any state do for state 0. If state is 1, actually, we're not doing anything for state 1 either, but if state is 2, there is some comments here to see how you should use these state do. You will need to think about how to implement some of the custom events here as well. So that's basically what we are going to do. What do we do in the model? We're doing move ball. Okay. Now notice that there is actually a couple of extra things we are also doing. Although the model only saying move ball, it also needs to check for whether the ball went out of bounds. And move ball does tell me that. Okay. So let's create move ball, and just to give you a reminder, when we look at the code, and this is the reason why in ping-pong classes, when we moved the ball, it returns a Boolean when it went out of bounds, right? So that is the part that is important. So we're going to move the ball, and we're going to check if the ball went out of bounds, and if it did go out of bounds, we're going to cause that, make that event to happen. All right, so let's create that move ball method. And actually, since it's only used here, let's create right there. We're moving the ball in a particular direction. So we're going to move the ball and see if it went out of bounds. If it went out of bounds, we're going to process that event because that's the way you tell the state model that that event happened. State model does not know what out of bounds is. It basically relies on the controller to determine when that event happened, and you call the state model and say, hey, out of bound event happened. You do whatever you need to do with that model. So now in here, all we have to do now is we will call self.moveBall. And this is going for state 2, this is going to the right. So we will say direction is right. Okay, let's take a look at our also do move ball 1. And we have processed out of bounds. So we're good to go. Okay, so that's basically how this works. And what is cool is now we can actually test it out. And let's see if this happens. Now, of course, not everything will happen because we haven't implemented everything yet. So let's press a key. We go to P1 to serve. And now when P1 serves, we should hopefully see the ball moving. There we go. Ball moves. Right? And a ball moves, went out of bounds. See? From state 2, it got transitioned to state 4 on out of bounds. But of course, nothing happens in out of bounds because we haven't done anything for state 4 yet. Okay, so we're going to speed up a little bit now and start putting in much of these functionality to the code. But I'm going to go over all of these. Now, in this implementation, we're not using state event. We're not using state left. We have stateDo for only 2 states, right? So there is stateDo is for move state 2 and state 6. Actually, let's do the state 6 as well. That's super simple. If state equals 2, do this. Elif state equals 6. We move the ball in the other direction. Self.move ball in -1. So that's the only thing. So we're done with stateDo as well. So only thing we have now left is all of these other state entries. 0 is done, 1 is done. We need for 3, 4, 5, 7, 8, and 9. All right, so let's see. If state is 3, what are we doing in state 3? We're checking for foul or hit, right? Again, we're checking for foul or hit, and that will give us either a foul or a valid return, and then we will need to process that valid return, right? So if we go in here, result is, sorry, player 2. So we check foul or hit for player 2, and if that is a valid return, we process event valid return, or we process event foul. Now, what is this check foul or hit? This is something we will need to implement. So let's go ahead and implement that. So check foul or hit takes a player, right? And it checks to see if when the player hit the ball, if the ball was in the right position. So we look at the ball's position. So we look at the game from the game, we get the position of the ball. And if that ball's position happens to be the player's home, then it's a valid hit. Then it returns true. So we can actually say bool here just to make it more clear. And absolutely having comments that say what it's supposed to be doing checks to see if the ball's position is the same as the player's home. If that's true, I return true. Otherwise, I return false. All right, so, and when it's true, I process event valid return. When it's false, I process event foul. Again, remember that the state model only knows the names of the events. It does not know anything about what these events mean. So the controller needs to tell the state model when these events happen and ask it to process the event. State 4 in our model says give the player some points. So we are awarding the player some points. This is also going to be a good place to maybe show a score, right? So what we're going to do is we're going to create a couple of methods. One is called player point. Player point, we are awarding the player 1 point, right? And remember that our player point class, point method returns that back. Okay, so that way we know whether the game got over or not. Because anytime we give the player a point, if the player got to 10 points, the game is over. So what we will do in player point is we will award the player a point, we will show the score, right? And if the player P is equals 10, so if the player won, we will say the game is over. And so at that point, we can process the game over method. Now we haven't implemented show score. That's a super simple method. So let's say, what does show score do? It's going to clear that top line, and then it's going to say the name of the player, the score of the player, and then the name of the other player, P2, and the score of the other player, P2, on line 0. That's basically what show score is doing. Okay, so that's essentially what that does. Let's keep going and let's implement the other entries. So here it is, state 3 and state 4. State 5 is player 2's serve. We already know how to do that. State 7 is check foul or hit on player 1, because when in state 7, ball is moving this way, it's player 1's turn to valid return or hit, and player 1 point, and then shows that as game over when the game finishes. And that is pretty much it. So let's run this thing and see if we have any errors. Welcome to Pong. We're going to press a key. P1 to serve. Let's get P1 some points. There you go. P1 is now 1, P2 is 0, P1 to serve. So let's try to see if we can return. Ah, it returns. We are so close to the game over condition. Let's see if the game over is properly done. Player is 10, state entered, state 9, we say game over, so we're getting game over. Probably would be good to say who is the player that won. Okay, so everything works fine, it's just too fast. Now to slow it down, there is actually a simple way to slow things down. And if you look at the run method in the controller, stateDo, there is run, and there is stop. So you will see that in the run method, you can actually slow things down. Normally, it's 1/10 of a second before each loop. I'm going to change this to maybe 0.2 seconds. That should be a little slower, so we can do this. Okay, player 1 to serve. Now, as you can see, it's a lot slower. So we can I hit too early, so it was a foul. Let's give player 2 a point. Now we're going to see something cool. Player 2 got a point. Ball color now changed to blue because it's player 2's serve. That was a simple little thing. By giving the player his own color, we can make the ball reset to that player's color. And we have a fully functional ping pong game with changing colors, and we did not use any help from AI today. Now, for your implementations, if you were doing something similar to that, you probably should find a middle ground. Of course, you're going to use the state model, But some of these methods, when you create these implementations of some of these methods, you can ask AI to give you implementations of the methods. And that's perfectly okay to do. But you need to be in control and say how your game actually works. Now, one thing that I should quickly, before we end this video, I am going to show you the one other thing that we talked about, and hopefully that will make sense now. So this is where the player one return or foul. So a couple of things we did off camera was I created a use case diagram. In use case diagram, there are all of these use cases: player one serves, player one returns, or player one fouls. So that's basically something that sort of together, right? Player one pushes the button. We probably should say something like pushes button or something like that, right? So that's player one initiates the serve and the return, and player two also initiates the serve and the return. Now, let's take a look at this. So player one returns or fouls. So this is the use case that we implement in this sequence model. So player one pushes the button. And remember that the button press is now handled by the state model. So that message goes to state model. State model figures out that when that button is pressed, we need to go to state 7. So at this point, they were already in state 6, or ball was moving towards the player. So it was whichever state we were going to. And state 7, so this is where you have that alt condition where state is 7. We're going to call self-call check foul or hit. And if the result is true, then we will do a valid return. Otherwise, we will do a foul, right? So let's take a look at the sequence diagram and see how that works out. So in state 7, we call check foul or hit. So notice that it's a self call. So that's this guy, the self message, not necessarily a recursive message. It's a self message. And then when you get that back in here, so let's take a look at check foul or hit. So check foul or hit is getting the ball's position and the player's home, right? So we are checking the ball's position from the ball, and we're getting the player's home from the player. So this is the message that we're sending to player: give me your home. Player returns back its home. We're asking the ball for its position, getting that back. And now if home is equal to position, right? So if ball position is equal to player's home, then it returns true. And when you return true, probably another step that I should have done. If it returns true, then we do a valid return. So if this is home is equal to position, we process event valid return. If it is not position, we return false. And so now we process event foul. So that's the sequence that happens. So, and that's basically what this sequence diagram does. Pause the video if you need to look back and forth between these, because it's important to understand how the sequence diagrams work, because you're kind of using these sequence diagrams to determine whether or not your system works or not. And as you can see, that this sequence diagram only implements the stateEntered for state 7. You should only create sequence diagrams for complex sequences that you should test on. Maybe you have a bug in your code, and so you should create a sequence diagram for the part of the code that is not working correctly, and then you follow the sequence diagram and the actual running of the code, and then you can decide whether it worked or not. We did not use any AI today. It's a beautifully working game, and we have full control over what is happening in the game. So if something does not work, we can actually make it, we can look at the log messages and see how that works out. So Hope this was useful. We are going to be building other applications using similar techniques, but this is probably a fairly complicated video. So I spent a lot longer than what I planned to, but in future videos, I'm going to make a lot of things time-lapse or pre-prepared code for you guys. All right. Hope this was useful, and I will see you in the next video.